Okay, this is an example of integral with a trigonometric substitution. Let's do, in this case, a and b are constants. They are just numbers, any number that we want, and the variable here is t. Okay. In this case, let's select t will be the square root of a over b, and you will see why I choose this. Multiplied by the tangent of the angle theta. Okay. In this case, the derivative of t will be, okay, this part is just a number, so we keep that a over b right inside of the square root, multiplied by the derivative of tangent, which is secant squared of theta by the derivative of theta, right? If we do this change, we also need to replace the limits, right? In this case, when t is 0, okay, it is easy to know that the theta also will be 0, right? When t tends to be infinity, because we never reach infinity, we tends to go to infinity, then we can say that that happens when theta, the angle, goes to pi over 2. And you know why, right? Because if we have the tangent functions is going like this, and we have an asymptote here in pi over 2, right? Okay, then let's start with the integral. If we do the substitution, we are going from 0 to pi over 2 of, what do we have here? We have the derivative. The derivative is all this, right? The square root of a over b secant square of theta, derivative of theta over what? We have the a, we have the b, but this t, we change this t, right, for everything here. We have square root of a over b, right, squared, tangent squared, right, and everything this is on the square, and this exponent will go away with the square root, so a over b is outside of the square root. I can cancel the b's here, and I can subtract the a from both sides, right? Let's do it. So we have here the same pi over 2 of the square root of a over b secant square, right, from derivative, and we have here a, we extracted one a from here and the other a from here, so we have 1 plus the tangent square, right, of this, and everything square. And this is a trigonometric identity. Remember the trigonometric, the Pythagorean trigonometric identities. And we can substitute that for pi over 2, right? We have square root of a over b secant square, the derivative of the theta over a in this case a is squared, right? Squared with secant squared. Oh, squared over square is the fourth, okay. Of theta, right? And I forgot to say that this part is the identity of secant theta, right? This part that we have here is a number. This is just a constant number. So I think we can move it that away outside of the integral. We don't need that to have that inside of the integral. So we have a over b, right? Over 8 squared divide the integral of from 0 to pi 2, right? Of 1 over secant square of theta multiplied by the derivative of theta. But this is also again a trigonometric identity. Actually, it's not an identity as a Pythagorean. It's just by definition the secant is the inverse of the cosine. So the inverse of the secant is again the cosine, right? So basically all this part will be cosine, and because it's squared for theta, right? So we will have from 0 to pi over 2. Oh, I forgot to put all this, right? Square root of a over b over 8 squared of cosine squared of theta by the derivative of theta. And this is easy. I mean, this is actually already known solution for the integral, but I will remember you the steps here. You remember that the cosine, the squared of theta, is equal to 1 plus cosine of the double angle over 2, right? Oh, we can include this in our integral, and we will have this is the square root of a over b, right? Or 0 to pi 2 of this, right? 1 plus cosine over 2 the double angle by the derivative. And we can split this into different integrals, right? So we will have the again this a over b 8 squared that multiply to the integral from 0 to pi over 2 of 1/2, right? Right. The derivative of theta plus 1/2 also of integral 0 to pi over 2 of cosine the double angle on the theta, the derivative of theta, right? And we can do this separately. Let's do this part first. So this is a constant. It will go away, go outside. So we have 1/2 of the integral from 0 to pi over 2 of the derivative of theta, and that is immediately solution. It will go from with theta that will have to be from 0 to pi over 2, and of course the solution will be 1/2 that multiply this multiplied by pi over 2 or pi over 4, right? The second part, 1/2 from 0 to pi over 2 of cosine a double angle like this. How we do this? Okay, let's do a substitution here. U will be 2 theta. The derivative will be the u will be 2 the theta. So this means that the u is over 2 will be derivative of theta, right? And then I can say that I have 1/2 this cosine of u over 2 by the u, and this is equal to 1/2 that multiply sine of u over 2, right? And I can substitute it back here. Will be 1/2 multiply sine 2 double theta over 2. I will go from 0 to pi 2. But if we do this, whenever theta is 0, sine is 0, right? And whenever let's put it in here, right? We go sine of 2 that multiply by pi over 2, right? Minus sine of 0, right? So this is 0, and this will go away, and sine of pi is 0. So this part is 0. So in conclusion, if we put that back again to the initial integral, you will have that this is square root of a over b over a squared that multiplied pi over 4. But this look awful. Let's simplify that a little bit more. Let's put this inside. We have the square root of a, right? And multiply pi over a square square root of b. And I mean, we can do also something like a is 1/2 over a square root of b, and if we subtract 1/2, I mean the 2 to 1/2, we have a negative exponent again, so it will be on the bottom. So we have pi only alone, and we'll have 2. This is 3.5, right? Square root of b. I forgot the 4. Sorry. The 4 here, and the 4. And that's it. Thank you.